Algebra 2, 5.3, lesson 5.3, picking back up, we've got our second part. As we look at example 5 and the next two examples after it, we're going to see that the directions really change a lot. It's no longer just to factor, it's, in this case, to solve. And what you're going to see is the big difference is you have an equation for each and every one of these problems. Now in example 5, it's already factored, which is wonderful. Here's a first parenthesis, here's a second parenthesis. And guys, if you have groupings of A times B equals 0, I hope you'd agree that either A would equal 0 or B would equal 0. That would have to be the only way that could happen. Multiplying to 0, you need a 0 in the picture, right? So this is called the zero factor theorem. And the way we solve is we will take each parenthesis, once it's in this factored form, and we set it equal to 0, and we solve separately. So for our first equation, I will add a 1. Then I will divide by 5. I will have a fraction. I'll have v equals 1 over 5. For this second equation, I will just subtract a 7. And I'll have v equals negative 7. So your answers, there are in fact two of them, would be the fraction 1/5 and negative 7. We don't have answers like we had prior, with in factored form with parentheses. Here we get specific numbers. Now when we look at number 6, you're going to see that unfortunately we don't have a factored form on the left. So what we'll do is we'll first factor. We'll make ourselves a little wheel. And we know that we need to multiply to a positive 2. We're going to have to add the number in the middle there is negative 3. And guys, focus on the multiplication to the number 2. There are only a very few ways you can multiply to a 2 with whole numbers or integers. You need a 1, you need a 2. And of course, we know that as we're going to be adding to something negative, it wouldn't be appropriate to have both of these numbers be positive. A 1 plus 2 would actually give you a positive 3. But realize when you're multiplying to positive 2, you could also do that if both of the numbers were negative. In other words, negative 1 times negative 2 would still multiply to a positive 2. A negative times a negative is a positive. But here's the important part. Now I can add negative 1 plus negative 2 and get negative 3. So the correct numbers in this puzzle would be a negative 1 and a negative 2. So we'll have u minus 1. All right, we had a little jump there. U minus 1 and also u minus 2. Now, if you were factoring, you'd be done. You would find your two parentheses, but this is solving. What you want to do is take these two parentheses and set them equal to 0. And as you solve, you can add a 1 to both sides. You'd get u is equal to 1. Here I'll just add a 2 to both sides. I'll get u is equal to 2. And guys, here are your two answers that you're coming up with. We have one last problem. And this might be the most different of them all. First of all, we do need to factor. We do have an equation that we need to solve, but the left-hand side needs to be factored. But stating the obvious, look at this left-hand side. We have 2 terms instead of 3. That's the first time we've seen that happen. And we also are going to notice that the lead coefficient, the number in front, is no longer a 1. It's actually a 5 here. So when it comes to factoring, what we're going to try to do is always factor out the GCF, the greatest common factor, the biggest number that divides into all of these terms without a remainder. Here's a hint. The lead coefficient is 5. Try to see if you can divide everything by 5. Negative 10 divided by 5, that works out evenly. That's good news. See, factoring in this regard will be undistributing. But you can see we have an x squared and an x. You can always take your smallest power of x away. And what's going to happen is you're dividing this by 5x. If distributing is multiplying, factoring is dividing. So imagine that I was dividing 5x squared by 5x. I'd just have a 1, and I'd lose one of my x's. X squared would cancel with that. Imagine that I was dividing the minus 10x by 5x. Well, negative 10 divided by 5, that would be a minus 2, and these x's would be gone. So that's really what's going to happen here. If you're ever worried or nervous that you've not factored correctly, you can redistribute, you could remultiply. 5x times x is 5x squared, and 5x times minus 2 is minus 10x. Well, we're not done. We actually are going to set each of these groupings equal to 0, just like we've been doing up above. Here I divide by 5, I'll get x equals 0. Here I'll add a 2, and I'll get x is equal to a 2. So here are your two answers, and that wraps up 5.3.